Multiplicative relationships are proportional, and they will always go through the origin on a graph. So remember, here's the origin. There's your horizontal number line with your vertical number line, and it will always go through the origin, which is where they intersect, right? So it's always going to be represented by this equation, y equals kx. Your k is known as something called the slope or the constant rate of change, which is what it will be called in 7th grade, okay? For us, it's just called multiplicative relationships. But just be familiar with those words. Now, here's a verbal description of a multiplicative relationship. Johnson can walk 2 miles every hour. So he can walk, so in 2 hours, he is able to walk 4 miles because he can walk, again, 2 miles every hour. So in every hour, if we pretend that this table has 1 hour, in every hour, he's able to walk 2 miles. So in 2 hours, 4 miles, 3 hours, 6 miles, and 4 hours, he can walk 8 miles. So if we look at this table, we can see the relationship between hours and miles, or x and y. To go from 1 to 2 by multiplying, you multiply by 2. And we can see that same relationship happening every time. 2 times 2 is 4, 3 times 2 is 6, and 4 times 2 is 8. So this makes this a multiplicative relationship because it's multiplying by 2. We're finding the relationship between x and y. Okay, and if we were to write this as an equation, which we're actually going to talk more about tomorrow, okay, we just bring down our x, we bring down our rule, which is times 2, because that's what's happening, and we're going to put equals y. But when we rewrite it in this form right here, y equals kx, we're going to rewrite it because we're going to rewrite it to where the y comes first, y equals kx. So this is just 2x, y equals 2x. Now, I've been telling you that tables and graphs kind of work together. So we're also going to graph these. Okay, so 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. That's my x-axis, remember. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. And if I'm going too fast, make sure you put pause to catch up. So on the bottom, we have our hours. Okay, this is the x-axis, so this is why our x is going here. Okay, now our y, which is miles, this is our miles over here. So when we graph it, we know that in 1 hour, he can walk 2 miles. So I'm going to put a dot there, put a point. Okay, look, and this is, again, this is the ordered pair. In 2 miles, he can walk in 2 hours, he can walk 4 miles, which, look, here's the ordered pair, 2, 4. In 3 hours, he's able to walk 6 miles. Again, 3, 6. And then in 4 hours, he can walk 8. There's that ordered pair as well. Okay? And even though it's not on the table, we know that in 5 hours, he can walk 10 because our verbal description tells us he can walk 2 miles every hour. Okay? And then when we draw our graph, we just connect the dots and the arrows go just like that. It's just as if this is quadrant 1. Pretend that there's a full 4 quadrant here. Okay? It only shows quadrant 1. It's going through the origin, so I can also see that this is a multiplicative relationship. Let's look at additive relationships. Additive relationships are non-proportional. I'm spelling that completely wrong. proportional, sorry. And it will not go through the origin, okay? So if I have my graph here, it's not going to go through the origin. Remember, here's the origin. It's not going through it, so that's what makes an additive, okay? And the equation that we typically see this as is y equals x plus b. And you'll learn this more, but b is where it goes through the y-intercept. That's where it crosses the y-axis. Okay, but you don't really need to know that yet. Now, your verbal description, Miss Wynn decided to give a 10-point curve on the unit test grades. So if we look here, here's the grade actually made, and then here's the final grade, which is also the curved grade, right? So if you look, if a student made a 60, he got plus 10 points. And the curved grade is 70. If he made a 70, he got plus 10 points to make an 80. An 80 plus 10 would be a 90. Okay, and then if we were to write the equation just by looking at this, I bring down my x, I bring down my plus 10, and it equals y. Okay, but again, to write it just like this way, the y comes first. So it's y equals x plus 10. So let's go ahead and graph this. I'm going to graph this. So the x-axis, right? I should be using my highlighter. My x goes on the x-axis, which is right here. Okay, this is the x-axis, so this is going to be the grade. And the y is going to be the final grade. That's the curved grades, right? So I'm going to count by tens on this graph. 10, 20, 30, 40, 50, 60, 70, 80, 90, and 100. Okay? And again, I'm going to do the same thing on the side. 10, 20, 30, 40, 50, 60, 70, 80, 90, 100. Again, if I'm going too fast, please don't hesitate to press pause. Okay, so if I make a 10, right? If I make a 10, I'm going to make my table here. This is x and y. If I make a 10 and I add 10, my curved grade is a 20. So I'm going to go ahead and graph here. A 10 to a 20. Okay? And then if I make a 20 and I add 10, the grade is going to be a 30. Remember, it's a 10-point curve, so you're adding. So if I go to 20, this is 30. Again, these are the ordered pairs. These are just ordered pairs. A 30 to a 40. We get the point, right? And look, as we're looking at it, it's going in the same direction. A 50 would be a 60. 60 would be a 70. 70 to an 80. 80 to a 90. A 90 would curve up to 100. Okay? So if I keep following this line, and I draw my graph and connect all the lines, I'm making my graph. Again, this is quadrant. Pretend this is a full graph. This is quadrant 1. Okay? This is how we would graph this additive relationship because you're adding 10. You're not multiplying like you were the last one. And again, it's not going through the origin, so this makes it additive. And it's actually crossing the y-axis. And this is what you're going to learn next year. This is the y-axis. It's crossing at the 10. And that is actually how you see that B means the y-intercept.